Yes. Hey, let's get started from Team 7. We have enough time today. Alright, let's get
Okay, hello, my name is Cindy Hall. I'm second presenter. Groups topic is vibration machine. Start our questions. Start from review of first presentation and explain the overview of vibration. Next, about the allocation and our goals. And he has found several ways to reduce vibration. Share CDL, AMD, and use MR fluid. So we'll discuss later. And we compare these three ideas and select one of these. And we're going to show our flat modeling for active method. So we'll start with a review of this presentation. Actually, vibration is mainly generated by mechanical imbalance, such as filling vibration from propeller or the unbalanced forces from the engine. And the waves also cause vibration on the ship. So whipping can cause a longitudinal displacement, and it's caused by the impact of wave. Springing also causes a traffic failure, which is caused by oscillating wave load. And there are several ways to make vibration, such as slamming or ventilation. So this vibration can occur structural fatigue, and it can be discomfortable for passenger on cruise ship, and vibration can damage to delicate cargo like glass. So to reduce the vibration, we suggest three methods. CDL is addition of constraint damping layer, and active mass EMD is active mass damper, which is adding mass, and use spectrometry. And last one is to use spectrometry bacteria. Use elemental reload cushioning and we'll discuss later. This is our team allocation. My part is to compare current idea and give a simple model. So in this presentation, we aim to provide the baseline comparison criteria and give a simple modeling. So this is our minimum goals. And for the final goal, we will show the effect of active mass damper using mathematical model. Okay, let's compare the different ideas. So we suggest three methods. To briefly explain how they work, active mass damper is a device that absorbs the vibration through additional mass. So we can control the amount of mass, and using MR fluid, it uses the viscous force of the fluid. So it can modulate the viscosity of the fluid by changing the magnetic field. The last one is CDL, which is constraint damping layer. CDL plays a similar role to MR fluid by using suppressing vibration using viscoelastic or other damping materials. It has a sandwich structure between two sheets, constraint layer and base plate. So it can suppress the vibration by converting the energy into heat. And here's our pros and cons of our three. In terms of installation, damping layer is easier than the others too, because it does not need structural change, while active bed damper and emerald fluid need structural change, so it must be designed. And especially
꺼버리시고 닫아버리면 돼요. 아니 저맨 왼쪽 거. 네. 그거. 네.
especially emerald fluid needs electromagnetic system, so it's more complex than the others too. And for maintenance, damping layer has high durability, since the damping layer is kind of changing material vessel. So once it's designed, it will not change anymore. An active mass damper and emerald fluid needs a regular inspection. Because damping layer has low initial cost, but considering the size of the ship, it will expense. And also active mass damper and emerald fluid are also expensive. So the damping layer can reduce structural fatigue. So it means it extends lifespan of structure. And active mass damper has high effective in canceling vibration, and it can cover a wide frequency band. But it's an expensive device. Lastly, emerald fluid controls magnetic fields by changing fluid viscosity. So it can customize the vibration damping case. So we choose active mass damper would be appropriate method for this because its adaptability and its efficiency. Active mass damper is the most effective method in reducing vibration, and we can change the amount of mass, so its adaptability is good. So we are going to design the active mass damper to maximize vibration reduction. In general, vibrations mainly comes from the engine. As you know, the ship's engine is really large, so we can't model it. So we want to model the small size using scaling. By assuming that the engine consists of reciprocating piston cylinder system, and supporting mount system. So the engine mount coupling system is modeled as follows. The structure is from the reciprocating piston cylinder system, and active mass damper is correspond the supporting mount. So by changing the strength of supporting mount, so we will change the value M2 of C2 K2. For the equation motion for this system is as follows. Without AMD case is expressed by simple second order differential equation, and the excitation force, we assume the excitation force acting on the engine is a sinusoidal function, because we consider the weight impact, and with AMD case, this equation motion can be expressed in matrix form. So MCK matrix are as follows. Okay, conclusion. I explained the overview vibration of the ship, so, such as where it's come from and how do we reduce. So we suggest 3 methods. And for adaptability and efficiency, we choose active mass damper of the appropriate method. And we present simple modeling for active mass damper. So in the future work, we will give more detailed modeling for active mass damper. And the final goal is to show the effect of AMD by changing amplitude or fixed time. Maybe it's related to the frequency response. Okay, this is our reference. Thank you for your listening. Is there any question? Question?
What's the weight of the active mass damper varies with the surge after shift?
Wow. Yeah, that's right. But maybe we refer some reference paper to use the AMD approach. Yes, that is a good point. Because the ship's engine is different case. So we will consider that point in the final presentation. I mean, we consider various mass range. So we will present in the final presentation. Another?
If the active mass damper be changed for a different type of the engines, like gasoline engine or diesel or equivalent. The one active mass damper can fight for all of that ship, or it should be better.
Any more? Yay. No? Right. It's good. You have already narrowed down the objective and problem is very clear comparing to the other teams and not big. So it's good. And also I see that comparison table is good. Okay. But still, you arrive at AMD is the choice, right? But I'm not sure why. So you need to elaborate more why you choose AMD comparing to. You show the narrative comparison, but you may say something like a quantitative numbers something or other item to show more sure that AMD is better than us. And for the question, it's similar to previous question that the choice can be dependent on context. What type of ship, what size of the ship, what type of engine, the situation or something is, we call this as context. So then you choose that at the title, you said that in the cruise ship.
Yes.
So it is very specific, right? But you did not say about cruise ship specific things in this presentation. So next time you need to show us why cruise ship, why AMD, they are fitting together each other. Probably other papers or research results saying they choose AMD for cruise ships. You may follow this, but you need to make audience believe in that your choice is scientific or something. All right, good. Thank you very much. We can then move on to team one.
Should I use the laptop here?
You can do, but you need to join the Zoom and share your screen, right? So you 공유된 거를 녹화하면 되니까. 뭐가 되는 거 아니야? 지리로 해보시죠, 여러분. 됐다.
Okay, so
스크린
그래서 화면 공유만 하고 이거는 줌으로 볼 수 있어요.
그러면 보여주고요.
So I'm Jin from Group 1. And this is our second presentation designing a Korean aircraft carrier powered by renewable energy. First, we're going to recap our previous presentation. So, first, South Korea recognized the necessity of an aircraft carrier, and on August of 2020, the introduction of an aircraft carrier was officially confirmed as a part of 2021-2025 Defense Midterm Plan. It is called the CVX project.
Can you say louder,
Sure.
slowly and louder?
However, due to the international treaty that we cannot weaponize the nuclear power, our minimum goal is to design a new renewable energy powered propulsion system for Korean aircraft carrier, and hopefully parallel with the long-term mobility and efficiency of the nuclear energy that many of the U.S. aircraft uses. So we're going to discuss about our aircraft carrier's specifications. So we are largely following the Hyundai CX-9, which has overall length of 270 meters and max speed of 30 knots, and light displacement of 30,000 tons and full load displacement of 50,000 tons. And it can support aircrafts which are 20 F-35Bs. And we're planning to suggest electric motor-based propulsion system and corresponding energy source, which would be the renewable energy. So then we're going to discuss about some renewable energy sources that we can use on our aircraft carriers. So first of which is the solar energy. As you might know, aircraft carriers have large flight deck and it is suitable for solar powered generation. So some advantage of solar energy would be that it can effectively utilize the wide deck area and it can produce up to 1.5 megawatts of electricity. We got that number from the known size of flight deck from the Indian aircraft carrier. It had pretty similar size to our specification, so we used that to calculate it. However, it also has some disadvantages. First, it cannot withstand the immense heat and impact from aircraft taking off and landing. So to mitigate that, you might be able to use some type solar arrays, as you can see in the video right here. However, it would add extra weight and some complexity. The next one would be thermoelectric energy. So aircraft carrier's flight deck reaches around 54 Celsius under direct sunlight and reaches up to 1000 degrees Celsius when in contact with jet exhaust. The temperature difference between the flight deck and the ambient, such as water and seawater, can be used to generate some electricity. So this method can utilize the thermal energy of the flight deck that is wasted otherwise. However, the Peltier element that is used to compare the heat thermal difference to electricity has such a low efficiency of 50% max. So it might say that it's not very energy efficient. And it is heavily time, location, and situation dependent. So in other words, you can only generate electricity when the ship is under direct sunlight and only in the daytime. And for the temperature difference that is for during the takeoff and landing, only then you can produce. So it is very situation dependent. And this one is the wind energy. So wind energy can be harnessed through either sails or wind turbines. A sail saves an average of 1.5 tons of fuel every day operation. And wind turbines produces up to 10 kilowatts of electricity per turbine. So the sail, as you can see in this image, it is already in development, and some of the ship uses this sail for the testing purpose, and figured out that that would save 1.5 tons of fuel every day of operation. So the pros would be its long-term cost efficiency, which is a characteristic of wind energy. However, the sails, such a big sail would hinder the aircraft operations. Even though it can be stowed, it takes time and it will hinder the quick operation of aircraft in emergency situations. And wind turbines would introduce extra drag when cruising. Final one is the ocean energy. So tidal stream generator installed in the bow and hull can be used to generate electricity. So we'll do one scale demo of EvoPod, which is the yellow thing right here. The 4.5 diameter rotor has demonstrated the capability producing up to 35 kilowatts of electricity. So, and to minimize drag during cruising, the turbines can either be stowed inside the hull or they're retracted above the waterline. The advantage would be its predictability in energy generation, because unlike solar energy and like wind, that is largely affected by the weather conditions, the tide and the current of the seawater, it is more predictable than the others. So we can say that it is predictable and more stable under conditions. However, it is like other renewable energies, it is largely location dependent and only usable when stationary or tethered. So with the generator extended out under the sea line, it would introduce a tremendous drag. So it may be not a good idea to cruise with the generators extended. The next part is the analysis on the requirements. So, knowing the required thrust that is needed to propel the ship in a constant speed is important when we choose the power source and motion method. So, when the ship, including an aircraft carrier, is moving on a constant speed, the thrust and drag would be the same. And the drag force, we can compute using this equation right here, where Cp is the total drag coefficient, rho is density of water, v for cruising velocity, and a for the wetted surface area. Unlike airplanes and stuff, for ships, we use a wetted surface area as the drag coefficients reference. First, we're gonna start by computing the total drag coefficient, CT. So CT consists of two components, which are CF and CR, which stands for friction drag coefficient and pressure and residual drag coefficient. Since the CF, the friction drag coefficient, takes up a major portion of the CT, we decided to compute the total drag coefficient by multiplying 1.1 to the friction drag coefficient. We are doing this because we can compute the friction drag coefficient by a simple approximation formula. However, for the CR, the residual drag coefficient, it is an involved process to compute, we either need computational simulation or a actual test with a scale model. So for the friction coefficient, we can use something called ITDC 1957 formula. It is the de facto standard formula of approximating the friction coefficient. And it uses the Reynolds number. Then we can simply calculate using the viscosity of the water and velocity and length of the ship. And for the multi-surface area, we're gonna use this simple approximation method that includes the LWL for waterline length and B and D for beam and draft respectively. So for the numbers here, we are likewise we did for the renewable approach analysis. We use this aircraft carrier of the similar size with known numbers. This is the carrier from and we got approximately 16,000 square meters for the surface area. So by combining all of these, we could get this required energies versus the cruise speed knots. So we figured out that for 13 knots, we require up to 3 meganewtons of thrust. So for the next presentations, we're gonna use this result to select more source and portion method. Final the feature plan. So in this presentation, we did analysis on the thrust required and comparison with renewable sources. And for the final presentation, we're gonna select the propulsion system and corresponding renewable source, and that'll be the end of the presentation. Thank you for watching.
Questions? Question?
I was gonna ask, do you know how much how the electric engines take? So yeah, all the electric engines. Also, we didn't do any analysis on that because that's for the next presentation. Okay.
Or J. Right. This team is also good for having a specific goal. It's good, but I see the goal is very tough one because there is no such example of any in the world having aircraft using renewable energy. No example, right? No sample. Because it is not easy, right? So you need to have a very big breakthrough to arrive at the conclusion. So it's a tough goal. And about the energy calculation, required calculation, you may not have enough time to calculate power requirement. So my suggestion is you try to know about the engine size of the Indian ship.
The engine size.
Right. The horsepower of the Indian ship engine size.
Oh.
So you may try to interpolate using that engine size. That may be the simpler, quicker estimation of power. Because your ship and Indian ship is similar, you said, but a little bit different, right? So you may adjust the number. So you may have a two tracks from the resistance or something like that, but from the top, the engine size of the engine ship can go down. There is another tip you can try. As you mentioned that the energy density of linear energy is very low. That's why they are using high-powered nuclear powers. So you cannot match using linear energy, the required power. So you may probably, I guess, you may use linear energy for the additional fuel cost saving
Yeah.
during say peacetime, not work. How can I say battle time? No battle time. Flight and running, you can use linear energy. But most of the time, maybe they can be idling or moving to another position. Right? Battle tower is very short. That's why you can try to reduce fuel cost by using linear energy. But it's still is tough. Also, renewable energy is very fluctuating production of energy. The sunshine, the wind, and tidal, they are not stable, right? They are fluctuating. Okay, good try. Good. All right, that's the part two. The next is final vision. All of us.
Hello everyone, my name is Timothy. Hello everyone, my name is Timothy. The topic of group 2 is antidial problem using bioelectrics. The presentation proceeds from introduction of antidial problem to future plan. First is introduction of antidial problem. Point. Let me talk first what is metformin. Metformin is the accumulation of organisms on surface like sheep, hole, or pipe, and propeller, leading to functional irritation. So vanish caused by metformin, it occurs on sheep hole, it increase hole roughness, and leading to increased fuel consumption and increase GHG emissions. Here GHG means greenhouse gas. That is key indicator for global warming potential. Next slide is necessity of anthropology and the graph on left shows increased GHG emissions depending on rainfall condition, and light is recoil proposal for with and without totally renewable. When in the mid stage, GHG emissions can increase by up to 55%, and with low cooling, power increase by approximately 1% over 5 years. But proactive cooling keeps it at a level of around 20 or 30%. Next slide is compared to next slide also compare no clean or always clean. And compared to no clean, always clean saves a total fuel cost of $8.81 million and reduce GHG emissions by 47,835 tons over the 5 years period. And anti-fire farming provide advantage not only in environmental aspect, but also in economic aspect. Next slide explains our group choose why choose electricity for anti-fire farming. First, anti-fire farming is become issue of international interest and it's evidenced by the upcoming global forum on anti-fire to be held in Busan this November. Additionally, fireballing regulations are being updated worldwide. Through this regulation, our group recognized equally and sustainable is an important factor in selecting anti-fouling methods. The choice is anti-fouling methods. We categorize biocide and non-biocide. First, coating using marine growth inhibitory agent is used toxic paint like TBT, which dissolve in seawater and to kill marine organisms. And also electric chemical and fouling use ionization of copper and zinc to kill marine organisms. That's why it's non-biocide. First, the coating utilizing friction resistance is used reduce resistance and to disrupt to attach marine organism. And electric base and fouling use electric effect and microorganism. If microorganism attach surface need bioelectric effect. So yes. And third, ultrasonic anti-fouling is used vibration to surface and it make disrupt attach micro and marine organism. Next slide is comparison of each methods. So based on table, our group concludes bioelectric based anti-fouling is most sustainable options. Next is implement biofouling based anti-fouling. Microcurrent is required, so a power supply is important. We will explain the possible methods for providing this power. The table provides power generation methods into two types: critical energy and mere energy. And this table is pros and cons of power generation methods. So utilization of this ship generator is first low extra need and stable and reliable. But cons is higher fuel use and not sustainable. And battery-based system is for constant power and risk generator better in the efficiency, but cons is limited capacitance needs and need charging infra. And renewable energy, solar energy is both sustainable and eco-friendly, but weather dependence require back space. And tongue means maybe might be unfamiliar to someone new. Tongue generator micro energy by harvesting vibrant emission. For example, ship engine or wave energy to produce electricity. Tongue source is self-powered and sustainable, and cons is yearly tech and need power management. First, present a table comparing various power generation methods based on multiple factors, such as eco-friendly or operating cost. Based on analysis, our firm concluded power is most sustainable options. However, correct conclusion, power-based bioelectric anti-gravity has shown promise potential as a sustainable and eco-friendly solution for marine applications. And further development and optimization are required to achieve large-scale deployment. And our Group 2 project called first minimum goal is design and performance testing a small-scale tongue-based bioelectric anti-firewalling system. And maximum goal is design and performance testing of a tongue-based bioelectric anti-firewalling system applicable to boat or small container ship, like under 1,000 TEU class. And future plan is first, research on tongue and bioelectric technology, and second, design of tongue-based bioelectric anti-firewalling system, and last, comparison of infections with the conversion system. That's why it's job application. And once, thank you for your attention. Do you have any question?
Questions?
One question. If the electricity directly goes through the hull of the ship itself, one is just blue.
네, correct. 네. bioelectric, bioelectric-based anti-bioelectric system이 surface electric 직접 풀려야 되니까 네, 직접 풀려야 색채정제 효과를 이용하려면 직접 풀려야 가능해서 직접 풀려야 됩니다.
And if it is the amount of energy generation by the renewable energy is sufficient to the use of the bioelectricity, it's a sufficient energy, amount of energy. We need to generate sufficient amount of energy from the renewable.
in reference, say 0.4 millijoule. 그 효과를 나타나게 하려면, 적어도 0.4 밀리볼트는 필요하다고 봤어서.
There's a voltage, but it's just about power, energy, amount, kilowatt or megawatt.
그거는 좀 더 조사를 해야 되겠습니다.
Any other questions? TA. I also has a similar question to him. So you next time you need to show us the mechanism of how the electric
bioelectric base.
based so mechanism you did not explain about how is it electric shock or how it works to eliminate power, right?
Yeah.
And then it looks like the topic is very specific, it's good, but it is very high level one comparing to our class. It is general introductory naval architecture, but your topic is very high level, something like a PhD thesis work or research project, something like that. So I suspect of that kind of a high level work is going outside of your team. I don't know, but I just guessing. But if it is so, then you need to say what is your team's own contribution, and something is borrowed from other team members or your laboratory or PhD work is or other international people has done this amount, but we did additionally something like this one is our own. So you can say if you apply a patent out of this work,
Yeah.
many people will want to participate in the patent to get money, right?
Mm.
So your own portion of patent, what is it? So that is the way you can separate out others' work and our work and division, right? So I don't know whether it is coming from another PhD work or project, but it looks like for me. And final one is Heng, TNG. I heard first time to me, even
Oh.
to me, right? I didn't know how it Heng. So is it based on vibrations?
It uses vibrant energy, change micro current.
Okay.
Yeah.
How?
Also, final
So you need to
explain.
explain other than okay, next time.
Yeah.
Right. It's a good idea, right? Somehow the mechanism of operation of tank can be explained in this next time. So because you are very talking about very high level research topic, it's good, but still too difficult for us to understand other audience or separate out your own contribution. All right. Good. One. Okay. Thank you earlier. So next week we'll have a special guest lecture. Worship then trained by Dr. Na. He has been work for Korean Navy for more than 30 years. Can expect good. Yes, teach. Any other question? No? See you next time.